Welcome to the Bare Metal Cyber Security Plus podcast. This series helps you prepare for the CompTIA Security Plus exam with focused explanations and practical context. For a companion study guide, check out the Achieve CompTIA Security Plus 701 Exam Success by Dr. Jason Edwards. It is the most concise and complete Security Plus guide on the market, built for busy professionals who want to pass the exam fast and on their first try. You can find this book and others at cyberauthor.me. In this episode, we're looking at architectural models, specifically on-premises infrastructure, centralized and decentralized control models, and how containerization and virtualization technologies impact security. Understanding these environments is crucial to designing secure systems and anticipating the unique risks associated with different infrastructure approaches. Let's begin with on-premises architectures. An on-premises system is one where all computing resources, including servers, storage, and networking equipment, are physically located and managed within an organization's facilities. The primary benefit of this setup is control. Organizations manage every aspect of the environment, from physical access to operating system configurations. This also helps with data sovereignty, keeping sensitive data within a defined jurisdiction and under direct organizational control. On-premises environments are common in industries with strict regulatory requirements, such as healthcare, finance, or defense. They are also favored by organizations that need predictable performance, low latency access, or full control over security policies. However, on-premises models come with risks. First, they require significant infrastructure management. Teams must handle hardware procurement, maintenance, power, cooling, and disaster recovery. Security is entirely the organization's responsibility, from patching systems to managing user access. On-premises architectures can also be less scalable. When demand increases, expanding resources often involves physical upgrades, which are slower and more expensive than scaling in the cloud. Now let's explore centralized versus decentralized models. In a centralized model, control is consolidated, usually in a data center or a primary management system. This makes it easier to enforce consistent policies, manage updates, and oversee activity. From a security standpoint, centralized architectures improve visibility and simplify incident response. You have fewer places to monitor and fewer systems to configure. But there's a downside. Centralized systems create a single point of failure. If the central hub is compromised or if it goes offline, it can impact the entire organization. This risk must be addressed with redundancy, backups, and failover strategies. In contrast, a decentralized model spreads control and services across multiple locations or systems. This might mean branch offices managing their own servers, or distributed systems operating independently across regions. The advantage here is resilience. If one part of the system fails or is compromised, the others can continue operating. However, decentralized models also introduce complexity. Policies must be synchronized across environments, logging must be collected from multiple sources, and incident response requires coordination across geographically dispersed teams. Without strong management, security inconsistencies can develop, making it harder to maintain a unified defense. Now let's look at containerization and virtualization, two technologies that support flexible and efficient computing, but also introduce unique security considerations. Containerization allows applications to run in lightweight, isolated environments that share the same operating system kernel. Containers are fast, portable, and scalable. Developers can package code and dependencies together, deploy it across environments, and manage containers using orchestration platforms like Kubernetes. From a security perspective, container isolation is key. Each container should be isolated from others and from the host system. If a container is compromised, proper isolation can prevent lateral movement. However, container sprawl, where too many containers are running without proper oversight, can lead to unmanaged risk. Without visibility and control, containers may run with excessive permissions or outdated software. To manage this risk, organizations should scan container images for vulnerabilities before deployment, limit root access, and use namespaces and C groups to enforce isolation. Network policies and firewalls should also be applied at the container level to restrict communication paths. Virtualization, on the other hand, uses hypervisors to run multiple virtual machines on a single physical host. Each virtual machine has its own operating system and runs independently from others. This model allows for strong isolation, flexible resource allocation, and efficient hardware use. The main security concern in virtualization is virtual machine escape. This occurs when a process inside one virtual machine breaks out of its environment and accesses the host or other virtual machines. While rare, these attacks can be devastating, giving attackers control over the entire virtual infrastructure. Other risks include improper resource allocation, weak network segmentation between virtual machines, and misconfigured hypervisors. To secure virtual environments, organizations should use patched and hardened hypervisors, implement strict access controls on the management plane, and monitor traffic between virtual machines for unusual activity. Regular audits of virtual machine configurations and consistent application of security baselines help reduce risk. As you prepare for the Security Plus exam, understand the trade-offs between on-premises, centralized, and decentralized architectures. Be able to explain when physical control is preferred, when centralized control simplifies security, and when decentralization improves resilience. Know the key security considerations for both containers and virtual machines, especially isolation, visibility, and misconfiguration risks. You may be asked to choose the right model for a business requirement or identify weaknesses in a virtual or containerized environment. Thanks for joining us for this episode of the Bare Metal Cybersecurity Plus podcast. For more episodes, tools, and study support, visit us at baremetalcyber.com. And before you take the test, make sure to check out the practice questions in the book Achieve CompTIA Security Plus SY0-701 Exam Success by Dr. Jason Edwards. They cover every domain and are a powerful way to lock in your knowledge.